Everyone, welcome to our channel TechWiseRahul. So today we are going to do the setup for Kubernetes cluster with the help of Kubeadm. Okay, so I am going to do this setup on my GCP virtual machine, which has a Debian as an operating system. So let me show you my setup. So this is the GCP VM which I have provisioned with Debian as an operating system, and I have already connected with my virtual machine with SSH. Okay, after copying the gcloud command. And let me show you. Before we begin, we need at least some prerequisite that required for particular VM to support the Kubernetes cluster installation. So we are going to do the first setup for control plane, then we will do the setup for worker node. So for control plane setup, we require at least 2 GB of RAM and 2 CPUs required on a machine to work as a control plane. Okay, so as we have already fulfilled this requirement, what next steps that we have to do? We need to install the container runtime first, and after container runtime, we need to install container runtime interface, and after that, we have to enable pod network add-ons, and we need to enable IPv4 forwarding as well. So let's start with container runtime first. So basically, when we are going to install the container runtime, let me show you, let me tell you some introduction about the container runtime. So basically, container runtime is nothing is a software component that required for managing the container. Either it would be deletions, executions, or creations. Okay. So as of now, there are multiple options available for container runtime. So container D, Cryo, Docker Engine, and Mirantis container runtime. So in our Kubernetes cluster setup with Kubeadm, we are going with Docker Engine. So let me open this in a new tab. Okay. So as we know that after installation of container runtime, we require a container runtime interface as well. Okay, so let's do the first setup for container runtime. Then I will tell you what's the difference between container runtime and container runtime interface and why we required it. Okay, now we are at the official page. As I have already told that my operating system is a Debian. So let me select this as Debian for supporting platform. And the OS requirement we have already fulfilled. I am using Debian and version for that is a 12, that is a stable one. Okay, so we are doing this from the scratch, so we can skip this one. For the installation, let's set up first app repository. Let's set up first Docker app repository on our VMs. Okay, that is done. That's very quick. Now we need to install the latest version from the Docker CLI and some Docker's component. It's asking for authentications. Okay, let's see. And after the installations, we can verify with the help of Docker run command with hello world image. Okay, system link has been created. Let's see, just wait for got our terminal back to run this command. Okay, now we got it. So I'm just running docker run hello world command. So it's pulled the image from the Docker hub and we got the response hello from Docker. So now we can conclude that our Docker engine has been installed successfully. So now clear the screen. Now the next step is we have to install the container runtime interface. Okay, so for supporting the container runtime interface for Docker engine is CRI Docker D. Okay, so let me tell you something about the container runtime interface first. So container runtime interface is nothing just like a standardized API that's allow or help Kubernetes to communicate with container runtime. Okay, so in earlier where Kubernetes is mainly used for orchestrating the Docker, but and going forward, we have a multiple options available in the market in terms of container runtime. Okay, as we have already seen in earlier page, this one. Let me show you. Yeah, container D, Cryo, and Mirantis. So to support all the container runtime, so there is a container runtime interface has been introduced so that irrespective of the container runtime, and Kubernetes will able to orchestrate any kind of container runtime with the help of container runtime interface. Okay, this is the main and basic difference with container runtime and a container runtime interface. That's why we required the setup to be done on VMs or host for Kubernetes cluster setup. Okay, so now let's do that. So now installing CRI Docker D. Okay, so let me tell you something that we are going to follow one GitHub link which I have created for installation for container runtime interface, because while doing the setup on, you're going to stuck somewhere. Okay, some instructions are not mentioned over the official documentations correctly. So I have already updated in my GitHub repo. No need to worry about that. I will share this my GitHub repo in my description of this video. Okay, so for set up this try Docker D as a container runtime interface, we require the Go language. Okay, so let's first install the Go language and set it into our path variable. Okay, now it's installing. After this part is done, now we are good to install CRI Docker D. Let's do that. Okay, now we are after cloning the repository, we are changing the directory as well. So let me show you that Go is installed. Okay, Go is installed with version 1.20.5. Okay, so this is the repository which I'm currently following, Kubernetes cluster setup VM. I will share this link in our description for this video. Okay, now we are going to build the CRI Docker D with the help of Go command. Okay, it will take some time. Okay, till the time that we can discuss about the pod network add-ons. Okay, so what is pod network add-on? So basically it helps that it's an additional, we can say that extensions or plugins which required for Kubernetes cluster setup, so that pod would communicate with each others, and nodes can communicate to pods, vice versa, without a NAT. Okay, we don't require a network address translator. So this the feature is being provided. Extension or plugins is gonna help to get these features. Okay, so for there are multiple pod networks add-ons available in the market. Okay, as an open source. So we are just like as Calico, VNet, we are going to see those as well. Okay, what are the options? So in our setup, we are going with Calico. Okay, we'll do that. Let's see if our Go language has built the CRI Docker D. Okay, it's not. Just wait for a few more seconds. Now we can see that after waiting for a few minutes that we can see that our CRI Docker D has been built. Okay, let's see what next steps that we have to follow. We have to create a directory mkdir-p usr bin, and then we need to install it and change it. Install in that particular usr local bin. Let's copy this all command and do it. Okay, in one go. Okay, I just copy it. Let me clear the screen and paste it. Now it's all done. Now we have to reload the domain and enable the CRI docker.service. Okay, now it's enabled. Let me show you as well. Systemctl status CRI docker.socket. Okay, now it's listening and active and running. Okay, so now this part has been done. What's the next steps that we have to do? Now we have already installed the container runtime interface. Now the So after the installation of container runtime and the container runtime interface, we need to enable the IPv4 forwarding on host. So let me tell you some background about that, why we are doing so. So basically, it's enabling the IPv4 packet forwarding means that it's a kind of networking stack technology or features which provides that a packet can be transfer from one interface to another. So this is very crucial in Kubernetes cluster setup, because so that our pods can communicate to each other irrespective of their positions or available in the cluster, just like so they can communicate each other after enabling this. So let me do that. Okay, I just copy it and paste it in our master. So same we have to do on worker node as well. Okay, same we will do on worker node for enabling the IPv4 forwarding. Next part is that we have to install kubectl, Kubeadm, and kubelet on this VM control plane node. Okay, so installing the Kubeadm, what we have to do. Okay, this we are going to pass in our sudo Kubeadm initialize command. Okay, let's update our VMs if any package is missing. Okay, this has been done. So now install the Kubernetes package index. Okay, that's done. Download the public signing key. echo it and replace it if there will be any keys available for the same locations. Okay, that is done. Now install the kubectl, kubelet, and kubeadm on VM. Okay, now it's installing. Now after that we can enable our kubelet. Okay, we'll do that. Just wait for a few seconds. Okay, that's all done. Now let's enable it. Okay, now this kubelet, kubectl, and kubeadm has been installed. Okay, you can see that kubeadm version. Okay, we have 1.30 version which is matching with the Kubernetes. Okay, after this, what we have to do that use Kubeadm to create a cluster. Okay, as I have told you that, let me show you first. Okay, what's the error we will get from there? We will understand that why we need it. Pod network add-on. So we just mentioned that sudo kubeadm. This is the command that we have to run for initializing it. The first part is that we can see that the error is coming that there are multiple CRI endpoints available on the host. So we need to pass which we haven't installed. That is CRI hyphen socket is equal to CRI docker d which we have installed. We'll mention this one. Okay, and after that, as I told, we are going to use a pod network add-ons and as a Calico. So we need to pass that command IP and this range from where I got this. This is available on official documentations of Calico. Okay, I just got it from there. Now I'm initializing my cluster control plane. We can say that, and that with the help of Kubeadm. Let's wait for a few more minutes to this Kubeadm setup to be done, or cluster setup for control plane node. Let's see. Static pod has been created. Kube API server, Kube control manager, and Kube scheduler. Our manifest file has been uploaded. Okay, now we are good. For start using the cluster, we need to run the following as a user. Let me show you if we didn't run this. Okay, let me make a copy of this first. Okay, I have it at my clipboard. Let's clear the screen. So our cluster is already, our control plane node is already ready. Let me try to run this command. So we need to run that particular command to create a .q file in our home directory so that it will be able to authenticate that we are trying to run from the correct user. So kubectl get nodes. Now we are getting. Now as you can see here, the status is showing as not ready. So let me tell you why. Kubectl get pods -a. Okay, so the core DNS pod is in pending state. As we can see that this is required for networking solutions or DNS problem, DNS name resolutions required in Kubernetes cluster. And we have used the pod network add-ons as a Calico, but we didn't that. So we need to deploy the Calico as well, apply the manifest for that. Okay, I have already mentioned all the information in my GitHub repo. You can follow the same thing. Okay, it's not an issue. I'm going to download the repository for Calico CNI Container Network Interface plugin as a CNI. Okay, now it's been done. Let me verify it with the help of ls. The configuration file for CNI would be in /etc folder /etc folder. Okay, as we can see here, it's available there. So let's clear the screen and now let's see it. kubectl get pods -a. Now it's running. Let's see again. Okay, it started running. Okay, all the pods are running, so we are good. Let's see the status of node now. kubectl get nodes. Okay, now our control plane is ready. Now we'll do the same setup for our worker node and we'll join it. We'll join that worker node to our control plane. Okay, so let me create an instance very quick. As you can see here, my worker node is ready and I just copy the command, gcloud command to have an SSH connection with this VM. I have opened a new Cloud Shell editor to have a connectivity and perform that Kubernetes cluster setup with Kubeadm on that. Now we are logged in. What we have to do, let's first update this VM sudo apt-get update -y. Okay, it's updating the package. For worker node, we need to install docker.io and enabling it. This is the steps that we have to follow. Let's do that. The same steps that we have to follow. We need to install the container runtime interface and then kubectl, kubelet, and kubeadm utility. Then after that, we can run the kubeadm join command to join this particular VM as a worker node to the our control plane node. We are going to install our libraries, kubelet, kubectl, and kubeadm. Okay, follow the same instructions which is mentioned there on the official documentation page. Copying the public signing key. Okay, after that, do the echo for the public signing key. Echo part is done. Now we need to install the kubectl, kubeadm, and kubelet on this VM. After starting, we need to enable the kubelet. Okay, just wait for a few more minutes. Okay, it's unpacking the kubelet. Okay, it's all done. Now kubelet is enabled. Let's clear the screen. So now what we have to do, we need to join that worker node to our control plane, and let's do that. So for doing so, we have to run this command, kubeadm token create print join command. Now the token has been created with the kubeadm command. We need to run this on our worker node with sudo user. Okay, this node has been joined the cluster. Let's see that. kubectl get nodes. It's showing us not ready. Just wait for a few more minutes. kubectl get nodes not ready. Roles is not assigned. Okay, let me see here because kubelet is responsible. Systemctl status kubelet. It's running. Kubelet is running. Now let's see now. kubectl get nodes. Okay, now it's ready. Okay, so as we can see here, I have done the setup from scratch. One VM as a control plane and one VM as a worker node. I hope you guys follow the same to do the same setup at your end. And if you encountered any issues, any error while doing the setup with any other container runtime or container runtime interface, please feel free to comment on this video and we'll reach out to you and we'll try to help and answer all the questions or comments. Okay, I will paste my GitHub link in this reference for this video. Thank you for watching. See you in next video. Thank you for watching. Please like, share, and subscribe.